Hey everybody, and welcome back to McCardle Math Academy. In this video we will be looking at the utility of creating probability trees, and we will be specifically looking at the three bridges example. So let's consider this example. There's three bridges in a small town, and all of these bridges are in dire need of repairs. So engineers have estimated that Bridge 1 has a 12% chance of collapsing in the next year. All right, and Bridge 2 has a 6% chance, and Bridge 3 has a 20% chance of collapse. So the question is, what's the probability that exactly two of the bridges will collapse next year? All right, let's keep that in our mind. We're going to form our probability tree, and then we're going to come back to this question. Let's imagine that Buzz Lightyear is the guy who's in charge of keeping track of all the bridges. All right, so throughout the year, he keeps his eye on Bridge 1, Bridge 2, and Bridge 3. First, he's going to look at Bridge 1. Now, during that year, Bridge 1 either stayed up or it collapsed. So I've represented these possibilities on a tree diagram. So in the first instance, if you go up here, I've said that B1, and with the check, that means it just is still standing. Or on the bottom here, B1 has collapsed. So I'll use a red X for collapse. And I also have probability information about this. It's said that 12% chance that Bridge 1 will collapse, and therefore an 88% chance that it'll stay up. Now, once Buzz looks at Bridge 1 throughout the year, he's then going to go and check out Bridge 2 throughout the year. So there's going to be a new branch of the probability tree. So for each of the first scenarios, now I can have that Bridge 2 stays up or Bridge 2 collapses. Again, there's a 6% chance that it collapses, and therefore a 94% chance that it stays up. And same for the bottom branch here. And of course, we can do the same thing for Bridge 3. And you can see here I have either Bridge 3 stays up or Bridge 3 collapses. There's a 20% chance of collapse and therefore an 80% chance of it staying up. And these are all the possibilities, guys. So you can read this, you can interpret this as either Bridge 1 stays up and maybe Bridge 2 doesn't stay up and Bridge 3 does, or Bridge 1 stays up, Bridge 2 stays up, and maybe Bridge 3 collapses. And now we can consider the actual question. So recall that the question was, what's the probability that exactly two of the bridges will collapse next year? So what we have to do is take our highlighters, and we go through these branches and highlight all the branches that include two bridges collapsing. So for example, we can say that Bridge 1 stays up, and therefore I need Bridge 2 to collapse and Bridge 3 to collapse. So there's my first branch where I'd have exactly two collapsed bridges. I could also have Bridge 1 collapse, Bridge 2 collapse, and then Bridge 3 stay up. Or I could have Bridge 1 collapse, Bridge 2 stay up, and Bridge 3 collapse. So there's exactly three branches that I'm going to need to keep track of, and I'll label those. Here's my first branch, here's my first branch, my second branch, and my third branch of this probability tree. And to find the answer, guys, you just have to sum up the probabilities for each of those branches. Well, what does it mean to find a probability of a branch? Well, you just have to multiply across all of the pieces of that branch. So 0.88 times 0.06 times 0.2, and we add that to the product of this branch, and then the product of this branch. I'm going to move over to the side and do that here for you guys. And you can see when we take the sum of these branches, and for each branch, again, we're doing a product that we get by going along that branch. That's the product rule that we learned in the last section. When we take the sum of these branches, we will get 0.039. So we have about a 3.9% chance that exactly two bridges will collapse in the next year. All right, so let's go back up here and check out our tree diagram. You might say, well, that's great, but what if I was asked for the probability that exactly one of the bridges will collapse next year? Well, you use the same strategy, but you would just highlight the branches that have exactly one X in them, one collapsed bridge, and you sum up the probability for those branches, and you'll get your answer. All right, I hope this helps, guys. I'll see you next time.